Welcome everybody. We got an interesting question. Foremost, let me draw the figure. This is the circle given, and this is the diameter of the circle. There is a triangle drawn, an acute angle triangle that is drawn with BC being its base. So okay, so this is ABC. This is given to be an acute angle triangle, an acute triangle. And we are also given that APQ lie on the circle. Now this is a triangle APQ, and it has an orthocenter. Its orthocenter lie on the triangle. So what we need to do is we need to draw that APQ. So A is drawn there. So this is going to be P and this is going to be Q. And we will have to connect these 2 points. Okay. Now it is given in the question the orthocenter of APQ lie on the circle, right? Now you have to know what is an orthocenter. An orthocenter is nothing but the altitudes of, or I should say the altitudes drawn from each of the vertices. They intersect at a point. Now what I wish to do is I'm going to draw the altitudes. Now if I were to draw the altitudes, right, this is a acute angle triangle. So the orthocenter is going to be lying inside the triangle, and it is given that the orthocenter of APQ lies on the circle. So we have to make sure that the diagram is actually resembling the orthocenter, or I should say the point where the altitudes intersect. Okay, so if I were to, let me try and intersect the altitude. So if I were to try this, I want this to be the point of intersection. So from Q we are drawing a line, and K is the orthocenter. Now from A the altitude is dropped, and it will also intersect at this point. So K is the orthocenter. K is the orthocenter. Now you have to understand that orthocenters are created by the altitudes. So K is the orthocenter of APQ. Now what are we expected to do? We are expected to find BAC. What is this angle in degrees? That's a question. So ABC is an acute triangle. The orthocenter of APQ lies on the circle. This is the information given. BC is the diameter, and we are expected to get BAC. Now how are we going to do that? Now to do that, foremost what I wish to do is I would like to draw the triangle APQ. Let me draw the triangle APQ. Because the angles which I am going to be utilizing would be best understood only if the triangle APQ is drawn. So this is A, this is P, this is Q. Now the altitude is drawn from P to the side AQ, right? So this altitude will hit the side and it will make 90 degrees, right? So 90 degree here, 90 degree here. Now similarly from Q the altitude is drawn and this is going to be hitting the side and making an angle of 90 degrees. So this is going to be 90 degree. Now from A there is the altitude drawn and that is going to be intersecting at this particular point. Now this point is going to be my K. This point is my K. Now this entire thing is angle A. So what would this angle be? That's an important question you have to know. So what is angle Q equal to? That is going to be 90 minus A. Now next question, what is this angle going to be? Angle at P is equal to 90 minus A. So that is a very important observation you will have to know given angle A. So with that observation what I wish to do is APQ is the triangle and K is the orthocenter. So if K is the orthocenter, naturally we will be able to obtain KQA, right? So what would be KQA and KPA? So KQA is equal to 90 minus A and KPA is equal to 90 minus A. So these are two important points we have obtained. So KQA, so this is known, KQA is known and KPA is also known. So these two angles are known. I'll draw a new figure just to provide reinforcement. So as I mentioned to you in the illustration, angle KQA, this angle is going to be equal to 90 minus A and angle KQ, or I should say angle KPA is equal to 90 minus A. Okay, now what we are expected, we want angle BAC. So we want to know what exactly is this angle. Now what I wish to do is from B I will drop a perpendicular to Q. So let me do that. So this is the point Q and the perpendicular is dropped. Now this is going to be 90 degrees. So let me write that down. BQA is 90 degree and AQB will be equal to 90 degrees, right? So this entire angle, let me draw that for you. If this is 90, this entire angle is going to be 90 degrees. Now what I am interested is, I would have to get I know this angle, so I would have to get this angle which you see here, right? So yeah, so let me shade that. This angle is required. Now angle BQK is equal to, now as I mentioned to you, there is a 90 degrees over here. This entire angle is 90 degrees, so this is going to be angle BQA minus this angle. What is that? Angle KQA, right? Angle BQK, this part, is equal to angle BQA, this is 90. From 90 I am taking away this part, this region. Okay, fair enough. So what happens when you do that? So this is equal to 90, BQA is 90 minus KQA is 90 minus A, and this is going to give me 90 minus 90 plus A, which is equal to A, right? This is equal to A. Now this is a very important observation you have to make. B, P, K and Q, all of them lie on the circle, and what do they do? And they form a cyclic quadrilateral. This means, so B, P, K and Q, they're all on the circle, they form a quadrilateral, BP, PK and KQ. Now this means angle, the exterior angle P will be equal to the interior angle BQK, right? From the properties of the cyclic quadrilateral, the exterior angle, which you see here, let me place this as KP, this part has moved, this should have been like this, KPA, right? It should touch this line, it's not onto the circle, it should touch the line. So this exterior angle which you see here is equal to the angle BQK, which is inside the quadrilateral interior angle. So angle at P we know, what is that? That's nothing but 90 minus A. Angle BQK, what is BQK? It's A. So this means 2 times A is equal to 90. So A is equal to 90 divided by 2, which is equal to 45. So A is 45 degrees. And that means, which are required to form BAC, or I should say we are required to find BAC. BAC is 45 degrees. So that's the solution to this beautiful question. So this is the answer to this question. So thank you everybody, hope you enjoyed this beautiful question. Please like, share and subscribe to our channel until we meet again.